Good morning, Nerdfighters. It's Tuesday the 8th of January 2013. My name is Patrick and today I want to talk to you about binary. You probably know binary from such places as your computer, and the fact that we're able to talk right now is solely due to binary. But in this video, I want to explain all about what binary is and hopefully help you understand it in as simple terms as possible. Binary, or base 2 counting, is basically a system of counting that only uses 2 digits. The system of counting that you and I know and love uses 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and because of that we call the normal version base 10. Binary uses 2, hence base 2. The two that it uses are 0 and 1, and whilst numbers like 23 can look incomprehensible to the untrained eye, the system actually isn't too difficult to get your head around. First, let's take a look at the similarities that it shares with the base 10 system. When we count, we let each digit go up to 9 before we roll it over to the next unit. 19 becomes 20 and so on, until the next 9 is reached, at which point we roll it over again, and it's the same in binary. Because 9 is the biggest number in our base 10 system, that is when we roll it over, and in binary, the highest digit is 1. So when we reach 1, we have to roll it over. Thus, counting goes a bit like this. 0, 1, and 2. Then, again, we count over from the rightmost digit until that is at its largest, at which point we roll it over again. 3. And 4. Because both of our digits were 1s, they both had to be rolled over, and we put a new digit on the leftmost side, which represents 4. My god, it's like Crash Course, but without the budget. A good way of looking at binary is this. Each digit represents double the digit before it. So if you start with 1, which you always do, then the digit to its left represents 2, and the digit to the left of that represents 4, and then 8, and then if I had more room on my wall I would show you 16. I made a prop for it and everything. And 32, and then 64, and then 128, and so on and so on and so on, doubling each time you go to the left with a new digit. So let's take a look at this number here, 1010. We know that the 1s mean that we count up those digits that they represent, and in this case, because I've got my handy little chart open, we know that they equal 8 and 2. All we need to do is add up an 8 and 2, and we know that 1010 is equivalent to decimal 10. Okay, so you're probably looking at me like, Patrick, what's the point of this? Why would anybody need to use this? How is it useful? And to be honest with you, you're probably right. There isn't many uses for binary unless it's part of your job or something if you're a technician. It has very little use in everyday life. But for computers, it is super useful. With an electrical circuit, you can use 2 different states, on and off, to represent the 2 different numbers, 1 and 0 respectively. And it's much easier to teach that to a computer than to teach it 10 different states and 10 different digits. In fact, it's almost impossible, and even when it has been done, it's relatively very slow. As it is, a binary computer can calculate about 1,000 million binary calculations in 1 second, which is pretty fast. The only other usage for humans is basically showing off. I mean, it could be a party trick. A pretty geeky party trick nonetheless, but it's an impressive thing to do if you can count to over 1,000 on just your 10 fingers. So that's my very basic introduction to binary, a very simple counting system where the possibilities are infinite. I've been Patrick, thanks for watching. Tried to catch it, but it didn't.